have to be present to make this a probability distribution? They have to add up to 1. Good. The sum of all probabilities has to be 1. And what else? What about the probabilities themselves? They can't be greater than 1. They have to fall, all probabilities have to fall between 0 and 1. Whoops. All right. Oh my goodness. I don't want to close that window, but I'll just kind of put something up there. It's getting louder and louder. That's because you took his backpack off. All right. So in order for you to find your mean, your variance, and everything else, you could do x times p of x, and then add them all up. Take the sum of this, x times p of x, just bring this down, multiply this, keep going, and then add up all of these. This will give you your mean. And what was the mean? 1.87? Okay. That will give you your mean. But we said there's an easier way. You're going to have to find your standard deviation anyway. So we're going to put this in your L1, L2. Now make sure you still use one var-stat. The reason we use one var-stat instead of 2 is because you still only have one variable. That's what it's looking for. One variable is your x value. That's what's changing. Your x value is your variable going from 0 to 6. What kind of variable is this? Is this discrete or continuous? My x value. Discrete. They're only whole numbers. So from 0 to 6, we have your x values. So you're still only one variable. Just remember to put L1, and if you have the 83 calculators, comma, L2. And then you'll get your mean. Your mean is your x bar. We got a population standard deviation. We don't have a sample one because if you think back, when we did that table with the standard deviations and we divided by n to find a population, for the sample we did n minus 1. If they all add up to 1 and you do 1 minus 1, you cannot divide by 0. Therefore, if you're using your p of x and not your frequency, you're not going to get a sample standard deviation, which is fine. The variance, remember the variance because we do this backwards when we use our calculator. We have to take your standard deviation and square it. Go to VARS, to number 5, statistics, and then come down to the OX and square it. That actually gives you your true variance because what happens is when you round your variance, your standard deviation, and you square that rounded one, that's really not your true variance because you rounded it. So you want to get it before. Let the calculator pull out the real one. Your expected value is the same as your mean. So that should have also been 1.87. Your variance should have been 2.75. Sorry, 2.57. And your standard deviation, 1.604, something like that. Okay. And your expected value, same as your mean. Everybody okay with that? Right. Then we talked about, before the break, we talked about the difference between discrete, when we look at your variable, discrete and continuous. If you can say, I have a half of something, think of a number line. If you could say, here's my number line. I have 2 1/4 ounces, that's continuous. If you can only count certain things, like how many books you have, 1, 2, 3, that's discrete. The geyser eruptions, they're discrete because if it erupted at all, it counts as an eruption. And so that's where that one becomes discrete. The amount of sugar in pounds, you could have 1,000.1 pounds, right? You can have an in-between count. Everybody good with that? All right. Then I asked you again to do another chart. This one you had to find your probability. This is our old frequency distribution. When we started with the frequency distribution. When we're looking at your X values, these are the intensities of hurricanes. This time it had no zero, because if you have a zero intensity, you didn't have a hurricane. So they started at 1. Sometimes they have zeros and sometimes they don't. These are the numbers. This is the number of hurricanes. This is your frequency. This looks just like your frequency distribution table. Exactly like that. So when you do this, you're going to take the sum of this guy, the sum of this. What did the sum come out to be? 165. Thank you. Now, your P of X is the same exact as your relative frequency. Part over whole. 61, ignore this part right now. 61 over 165. And then generally, if you can, 3 decimals. All of these guys tell us they should be between 0 and 1, which they are. You can kind of see, thank God, that we don't have a lot of 5 hurricanes, because they're the real bad ones. We've got a lot of 1 hurricane, and it's odd that we have more 3s than 2s, but maybe that's just the way the things worked out. When you graph this, again, give me a title. This is where your X goes, this is where your Y goes. This is your relative frequency. Give me your probability here. These are your X values. Start it at 1, 2, 3. And these are bars. These bars should be touching. If I leave a little break, this one can start at 1. It's fine, because this is where your 0 is. Be careful when you do your P of X. Think of money. So this is my 37 cents, my 24 cents. I got to go up to like 40 cents. So if you can, go by 5 cents. 5 cents. If you can't, judge your time, go by a little bit more, a little bit less, whatever you can fit in. Try not to squeeze your graph into a little tiny piece at the bottom. Some of you I saw a little tiny graph, some of you I saw big. Try to use the space. That's another thing to look at. Use the space for your graph. And just make your bars. 37 cents. Think of money. 24 cents. As close as you can to estimate. Okay? Now you can definitely see this guy is skewed. And we're going to start looking at the skews in probably by tomorrow. It's skewed again. We have very few over here, so we can kind of see a skew to the right. Your larger numbers are falling in the beginning, and that's a good thing for hurricanes, isn't it? That our larger numbers fall with less intensities. So don't forget, give it a title, give it an X, give it a P of X. From this graph, from this table, you can figure out all your probabilities from here. Once you figure out your probabilities, when we get down to find the probability that a hurricane selected at random has an intensity of at least 4. At least 4 means 4 or more. So we go to your table and we add these 2 up. Everything comes right off your table at that point, so you don't have to calculate anything else. Your standard deviations again, if you do L1, L2, that's fine, or L1, L2, that's fine. If you do it with the decimals, the only thing you're going to miss is your sample standard deviation. That won't be there because of they all add up to 1. And we can't do 1 minus 1. We can't divide by 0. So does it kind of all come back to you? What we did before? I thought this would just be a good jump into this and remember things that we did.